Hi, in today's video I'll show you a cool math problem. I hope you like it as much as I did. So, let us begin. We want to find x, if x is a whole number, that is, it can be positive, negative or 0. The equation that we will be solving to find x is 8 to the power of x minus 2 to the power of x divided by 6 to the power of x minus 3 to the x, and all that is equal to 2. We will first write 8 as 2 to the power of 3, and 6 as 2 times 3, we will also use simple rules for exponents. With that being done, we now separate exponents in denominator and write 2 times 3 to the power of x, as 2 to the x times 3 to the x. In the numerator, we write 2 to the power of 3x, as 2 to the power of x plus 2x. We need to do that because we will then have common terms in the numerator that we can then factor in. We can now easily see that numerator and denominator have common terms. In the numerator that is 2 to the power of x, and in denominator that is 3 to the power of x. We then combine those terms in numerator and denominator. You can see that in the numerator we have 2 to the power of 2x minus 1. Using binomial theorem, we can write that term as 2 to the power of x minus 1 times 2 to the power of x plus 1. We did this, because we now have two common terms in numerator and denominator that we can cancel. So we cancel term 2 to the power of x minus 1. But, here we need to consider an important part. We can only cancel those terms, if the term in denominator is not equal to 0, that is, if 2 to the power of x minus 1 is not equal to 0. Using this condition, we easily see that x can't be equal to 0. With this, we found one value that x can't be. We still didn't find what x is, but we are getting there. We now get rid of the term in the denominator by multiplying the equation with 3 to the power of x. And then we divide everything by 2. And with that, we've done all we could to our equation. We now need to see what we can conclude by looking at our equation. We already know that x can't be equal to 0. Let's now see what happens if x is equal to 1. For x equal to 1, we have on the left-hand side, 2 to the power of 0, times 2 to the power of 1 plus 1, or in total, we have 3. On the right-hand side we have 3 to the power of 1, or simply 3. With that, we see that our equation is satisfied for x equals to 1. We've found one value for x, but we still need to look at other solutions that might exist. Let's see if x is greater than or equal to 2. In this case we can see that the first term on the left-hand side is always an even number, second term is always odd, and on the right-hand side we have a term that is also always odd. We know that an even number times an odd number is equal to an even number, but since the right-hand side is always odd, we can conclude that our equation is not satisfied for x greater than or equal to 2. With these three cases, we've looked for possible solutions for x, if x is greater than or equal to 0, and we found only one solution, x is equal to 1. But, at the beginning we said that x can also be negative, we need to check if there is a solution for x less than or equal to minus 1. Let's do that now. Since we are looking at negative numbers, we'll introduce a substitution for x that is x equals to minus n, where n is any positive number. Plugging that into our equation, and using simple algebraic manipulation where we make common denominator on the left-hand side, and then we get rid of denominators on both sides of our equation, we finally get the expression 3 to the power of n, times 2 to the power of n plus 1 is equal to 2 to the power of 2n plus 1. Here we have something similar to case 3. First term on the left-hand side is always an odd number, second term is also an odd number, and on the right-hand side we have an even number. Since we know that an odd number times an odd number is also an odd number, we conclude that x can't be less than or equal to minus 1. Taking into account all cases, we see that we have only one solution for x, and that is x is equal to 1. And that's it. We found what we were looking for, using simple algebraic manipulation and rules for exponents we managed to solve our equation. I hope I was clear enough, and thank you for watching.